All right, this is the second half of the review for the first exam in 1010. So 27 says, suppose REI sells 0-degree sleeping bags at a discounted price of $94.50. If this price represents a discount of 30% off the original selling price, then what's the original selling price? So remember, we have a number times a percent equals a new number. So now this is, the percent is 0.30. We don't know what it was originally going for, but we do know in the end it's selling for $94.50. So now to get this alone, we're going to divide both sides by 0.30. So our original price is, let's calculate it, $94.50 divided by 0.30. The original, whoa. Oh, it's, oh, uh-oh. 30% off. We've got to be so careful with this because it's actually not 30% we put here. If it's 30% off, we're actually timesing by 0.70. Now, why? Because 100% of the original price is going down by 30%, meaning 70% is what we're actually paying of the original price. That's why we got to type in 0.70. Oh, I almost got tricked right there. Now, how I caught it was when I did the math with 0.30, the original price was $315. So I knew something was wrong because it only went down by 30%. That shouldn't be so high. So anyways, $94.50 divided by 0.70. And that would have been $135 to begin with. All right, solve for x. So we get x alone. So I'm going to times by x to both sides. It divides out. xy equals k. Solve for x. So we divide by y. And we have x is equal to k over y. Solve for c. So I'd subtract 32. F minus 32 equals 9/5 c. Now I'm going to get rid of 9/5 very carefully. So I'm going to first get rid of divide by 5. What undoes divide by 5? Times by 5. So it divides out. So now I have 5, f minus 32. Make sure you use parentheses because when you times 5 over to this side, there were 2 terms. So you need parentheses. 9c, then divide by 9. And our c is all by itself now. So just be really careful, guys, with little things like if you have 2 terms, making sure to put parentheses if you were to times something over. Solve for w. Well, this one's pretty straightforward. Minus 2l. P minus 2l equals 2w. Divide by 2. And then don't accidentally divide out those 2's. You can't divide across a subtraction sign unless all 3 things divide by something in common, and they don't. So we have p minus 2l all over 2 equals w. All right, solve for m2. We're trying to get this part, m2 all by itself. All right, so I'm going to go ahead and subtract m1 v1. So I have the p minus m1 v1 equals m2 v2. So to get m2 by itself, divide by v2. And oops. Divide by v2, and m2 is now alone. So pretty straightforward, as you can see. All right, solve for t. Oh, pretty easy. We have one step problem here. Divide by nr, and now t is by itself. All right, solve for w. Now notice we have a problem where we have 2 w's. Remember, when this happens, we're going to get everything with a w on one side of the equation and anything that doesn't have a w to the other side. So I'm going to subtract 2lh from both sides. S minus 2lh equals 2lw plus 2wh. Now remember, at this point, we can now factor out our w. So I pull out the w, divide by w, divide by w. So then left in this term is 2l plus 2h. So divide both sides by 2l plus 2h. Divide by 2l plus 2h. And w is all by itself, so we would be done at this point. Okay, so this says solve for x. We're going to subtract 12. 3x is less than or equal to negative 12, divide by 3. X is less than or equal to negative 4. That's your solution. So remember, there are 3 ways to write the solution. There's set builder notation, the set for x, such that x is less than or equal to negative 4. Then there is interval notation. So that would be from negative infinity up to negative 4, because notice the arrow's pointing that way to negative infinity. Now I just made an error because it is equal to. When we have an equal to sign, we need to make sure we include it with a bracket. And then the last and final way is to show our number line. 0, negative 1, 2, 3, 4, negative 4. And then we can have a closed circle, and our solutions go to negative infinity. Pretty straightforward. Okay, number 60. So with this one, I'm going to subtract 1. We have 1 is less than negative 3x. Divide both sides by negative 3. Uh-oh, we just divided both sides of an inequality by negative. We need to change the sign of our inequality. So we have negative 1/3, and now is greater than x. Then just a reminder, in our final answer, when we do our set builder notation, we need to put x first. So we have x. Now look, it's chomping on negative 1/3. It's eating negative 1/3. So we're putting x first, but we've got to keep it eating negative 1/3. And then it looks like it's pointing this way. So that would be negative infinity up to negative 1/3. It was not including, so we put a parenthesis. So on a test, you just go ahead and not make it to anything too fancy, really. All right. All right, with this one, we're going to go ahead and solve for n. So I'm going to add 8 first. So now I have 1 is less than or equal to 3, n plus 1, divide by 3. You could distribute or you could divide. I'm going to just go ahead and divide by 3. 1/3. 1/3 is less than or equal to n plus 1, so then subtract 1. 1/3 minus 1 is less than or equal to n. We need to put these together, so let's get a common denominator. 1/3 minus 1, I write it as 1 over 1, then I times by 3, times by 3, so then I have 1 minus 1/3 minus 3/3, which is negative 2/3. All right, so we have negative 2/3 is less than or equal to n. Now this one actually probably would have, the algebra would have been easier just to distribute and then subtract 1 and then divide by 3. You wouldn't have had to get a common denominator in the end. But it's not bad to do it this way either. All right, so at this point now we're going to write it correctly, the set for n, such that, now notice we need to write n first, and it's munching on n, so it needs to stay munching on n. So yeah, n value is greater than or equal to negative 2/3. So now it's pointing that way. So that means we're starting at negative 2/3. It's equal to, I need to change this to a bracket, going to infinity. And then I think we're pretty good with the number line here. 0, negative 2/3. Let's go ahead and do a closed circle because it's including and point it that way. All right, pretty easy, straightforward stuff. All right, let's just be careful here to distribute. 3p minus 6 plus 5 minus p. We have parentheses, but there wasn't a negative or any number that needed to be distributed, so I didn't need to write them right there. It's greater than 2. Then we got to make sure we distribute the negative through, so that'd be minus p plus 3. Combine like terms, so that would be 2p minus 1 is greater than negative p plus 6. So now I'm going to go ahead and add p. 3p minus 1 is greater than 6. Add 1. Sorry, just making sure. Uh-oh, that's not 6, is it? 3 plus 2, I multiplied, but we should have been adding them, doing plus 5. So we actually have a plus 5 right here. We have a 5. So we add 1. So we have 3p is greater than 6. Divide by 3. P value is greater than 2. The set for p such that p is greater than 2. And then we would say it's pointing this way, and it's not including. So then we would have 2 to infinity. And let's do a bracket here. Nope, it's not including. My bad, my bad. I need to pay better attention. Parenthesis, not including to infinity. All right. Okay, same idea here. 5x minus 5 minus 7x is greater than, distribute, 4 minus 2x. So combining like terms here, we have a negative 2x minus 5 is greater than 4 minus 2x. Oh, add 2x, add 2x. So we have negative 5 is greater than 4. Now with this one, remember, if your variable cancels out, a couple things can happen. You can have all real numbers or no solution. So if we look at this, is this a true statement? Is negative 5 greater than 4? No, 4 is greater than negative 5. So since this is a not true statement, we're going to say no solution. Now if it would have been switched, let's pretend it would have said negative 5 is less than 4, that is true, that would have been all real numbers. So just a reminder on that. This one's a no solution one because it's not a true statement. So we could just write, the set for x such that x is no solution. You can't do interval notation if there's no solution. You can't do a number line if there's no solution. All right, with 67, just a reminder, it's best to get a common denominator, which looks like it's going to be 36. So we're going to times by 4, times by 4, times by 3. So then we have now 36, a 36, a 36. We can just solve with the numerator. Negative 16w plus 21 is less than 5. Subtract 21. Sorry, negative. So we have is less than negative 16, divide both sides by negative 16. We just divided both sides by a negative, so I need to change my inequality sign to the other side. So we have w is greater than 1. The set for w such that w is greater than 1. Now this one's not including, so we have, and it's pointing that way, so it would be 1 to infinity. And I think we get the picture with our number line. We'll do a open circle pointing that way. Pretty straightforward. Okay, let's get to 79. Now this is the one where it's a little bit harder for people on the test sometimes. You have to really remember what and versus or is. So just a reminder, and is the picky, it's the intersection. So only where they intersect. So you'll solve them individually. This one's solved. So it says x is less than 4. I like to write them in interval notation. Well, if that's true, notice it points that way. That would be negative infinity up to 4, not including 4. Now, if you need to give yourself a visual, what would that look like? Well, 4 would be our kind of like starting point. 4 getting smaller, so that would be 4, 3, 2, 1, 0, negative 1, and it would go into the negatives. Okay, let's do this one. Subtract 3. X value is greater than negative 1. So that would be pointing that way. Notice that would be negative 1 to infinity with a parenthesis because it's not including. So what would that look like? Negative 1, 0, 1, 2, 3, 4, 5, and to infinity. All right, so now it's the intersection. So let's see where these things intersect. This one starts at 4. This one goes forever. Well, the furthest we can go is 4 foreshore then. So we know we're gonna, the furthest we can go to the right is 4 based on this one. And the furthest we can go to the left on this one is negative 1. So same here, since that would be the intersecting point. So notice our interval for our solutions are between negative 1 to 4, and they both had parentheses. This was the intersection. So then we would say the set for x such that, put your x in the middle, put your lowest value on the bottom or above, and then look, it was munching on negative 1, so it needs, no it wasn't, it was munching on x. See, it's eating x, so it needs to stay eating x, and then right here, notice it is munching on the 4, so it needs to stay munching on the 4. And remember I told you the signs will always face the same way, and they do, so we're good. On our number line, we're going to go ahead and just do our parentheses. Our solutions are here. All right. Remember, if there is no words, it's automatically going to be an and one, but it will work out automatically. You don't even really have to think about it. because it will tell you that x is between two values. Like, it'll already do the math for you. You don't even have to really remember it's and, because the math will turn out to be and, as you will see. So we have 1 is less than negative x is less than 5. Divide both sides by negative 1. Oh, we just divided an inequality by a negative, so I need to change my signs. Negative 1 like that, x like that, and negative 5. Now, it's really best to rewrite this so that our lowest value is first. Now think about it, negative 5 is actually smaller than negative 1, so let's rewrite this. This is negative 5. Keep it munching on the correct thing. It needs to stay munching on x, because look, it's munching on x. And then it needs to stay munching on the negative 1. All right, so there is the set for x such that x is between negative 5 and negative 1. Well, if that's true, if x is between negative 5 and negative 1, it would make sense that our interval notation is negative 5 up to negative 1 like that. Negative 5, negative 1. Let's do open circles, because neither of those we're including. Ooh, this is an or, so this one's friendly. Either or gets to go. X is less than negative 2. And, or I mean not and, it's or x value is greater than 2 gets to go in our solution set. So let's look at this in interval notation. So it's pointing that way, so that would be negative infinity up to negative 2. Or also, basically, also pointing that way, 2 to infinity. So notice there's no overlap here. There's like a big gap. I mean, not a big gap, but a gap of numbers that aren't in our solution set, but everything is in our solution set from here over and here over, because or is joining them. So we'd say negative infinity up to negative 2 united with 2 to infinity. There's your interval notation, the set for x, such that, now remember, the or ones can stay separate, so we have x values less than negative 2, or x values greater than 2. All right, hopefully this is pretty straightforward for you all. Another or one, so let's just solve. Or is friendly. X value is greater than or equal to 4, so that would be 4 to infinity. So like 4, 5, 6, 7, 8, 9, 10, you get the picture there. Or x value is less than 0, so that would be negative infinity up to 0. That also gets a bracket, looks like 0 also gets a bracket. Either or answer gets to go. So if you look at this, we have from negative infinity up to 0, then we have this gap, and then we start at 4 to infinity again. So another one where we would say negative infinity up to 0, united with 4 to infinity. There was no overlap there, but united, both get to go. The set for x such that x is less than or equal to 0, or x is greater than or equal to 4. Now, they were brackets, so guess what I've messed up on? I need to go back and put a bracket here. Gotta stay consistent. So then we're gonna do a bracket to negative infinity, a bracket to positive infinity. All right, another and one, an intersection, -2. 3x is less than or equal to 3. X is less than or equal to 1. And, which is picky, it's gotta be intersection. So and, well, let's actually make our visual here. So an interval notation, negative infinity up to 1. So that would be like 1, 0, negative 1, negative 2, dot, dot, dot forever. And then this one, -2, negative 4x is less than or equal to negative 12. Divide both sides by -4. We've got to change our inequality sign. We just divided by a negative. Oh, so then, and at the same time. So then that would be from 3 to infinity. So that would be like 3, 4, 5, 6, dot, 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 forever that way. Now this one's and it's picky. They've got to like overlap. If there really is a solution here, they've got to overlap. Now this one goes from negative infinity up to 1, and then there's a gap of 2, like we're missing 2, and then it starts at 3. So there's no overlap here, so there is no solution. All right, another and one, remember, because it doesn't say anything. Negative 4 is less than or equal to 2x is less than 13, 12, 11, 10, 9, 8. Divide by 2. So we have negative 2x 4. So that's our solution. These ones are honestly one of the easiest ones because it just really does all the work for you. Like it tells you your x values are between negative 2 and 4. It's set for x such that x is between negative 2 and 4. So our interval is negative 2 to 4. But guess what I did not do correct? This one needed a bracket. And this one needs a parenthesis. Equal to bracket, not equal to parenthesis. All right, so let's be careful here. So this one gets a bracket, this one gets a parenthesis, and there's our solution. All right, another or one, like 3. X is less than or equal to negative 2, or, so let's look here, pointing this way, so negative infinity up to negative 2, bracket on the negative 2, so that would look like this. Negative 2, negative 3, negative 4, dot, 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 that way. All right, or minus 1, 2x is greater than 6 divided by 2, x value is greater than 3. Alrighty, so that would be 3 to infinity. Oh, this one's not bad at all. So 3, 4, 5, 6, that way forever. So we're uniting these. So once again, there is no overlap here, but it doesn't matter. We're not doing and, we're doing or, so we're uniting these. There is a gap between negative 2 and 3, so we're just going to unite those answers. So interval notation, negative infinity to negative 2, united with 3 to infinity. And then from there, our set notation, x values such that x is less than or equal to negative 2, or, just remember, or, you don't put them together, x value is greater than 3. I'm not going to draw the number line because I think you get the picture here. All right, we're down to our last couple examples here. We're almost done. Solve. Or x value is greater than negative 2. So that would be negative 2 to infinity. Point that way, notice. So that would be like negative 2, negative 1, 0, 1, 2, 3, 4, going that way forever. All right, let's do this one. Minus 4, negative 2x is greater than or equal to negative 10, divided by negative 2. X is, oh, we just divided by a negative. We've got to change our sign. Or, so this one's the friendly one, or x value is less than or equal to 5. So that goes this way. So notice that would be like, so starting with 5, including 5. So that would be negative infinity up to 5, bracket, parenthesis, negative 5, or 5, 4, 3, 2, 1, 0, and so on that way. Oh, notice they are pointing in opposite directions. Now, if this goes to infinity and this goes to negative infinity, and there's no gap here, so look, we have overlapping values. We have a lot of overlapping values here. So with that being the case, our domain on this one has all overlapping values, so negative infinity to infinity, where our solution is negative infinity to infinity, or all real numbers. So that's how we would write our interval notation, negative infinity to infinity, all real numbers. So we would say the set for x such that x is all real numbers. And then on our number line, our solutions will just go left and right forever. So once again, hopefully you can see how these completely overlap. So it would connect all the way through with no gaps. So that would make it, since it's OR, it's friendly, all real numbers. All right, looks like it's our almost last problem up here. All right, let's get a common denominator here. So times by 3, we can ignore the denominator. 1x is greater than 6. So x is greater than 6. So that would be 6 to infinity. Or get a common denominator, times by 5, 2x is less than, ignore your denominator at this point, negative 20, divide by 2. X value is less than negative 10. So then that would be negative 10. Oh, it's pointing that way. So it's actually negative infinity up to negative 10. All right, this is OR. So it's friendly. So once again, this one does have a gap. If you think about it, because we're going from, if we were to draw on our number line here, here's 0. We have our negative 10, and then we have our positive 6. So then either or answer gets to go. So if we're at negative 10, going to negative infinity, and 6 going to positive infinity, there's our number line. Notice there's a gap here, but it's an or, so it's friendly. So either answer gets to come. So we would say negative infinity, negative 10, united with 6 to infinity. Our domain, or I mean our set notation, set for x such that x is less than negative 10 or x is greater than 6. There's your set notation. All right, truly our last example is this. So let's go ahead and solve. So I get a common denominator. So I'm going to times by 2, times by 2, times by 2, times by 2. So I would have denominators can now be ignored. 2x plus 3 is greater than or equal to 0. 0 times 2 is 0. Subtract 3. 2x is greater than or equal to negative 3. Divide by 2. X is greater than or equal to negative 3/2. Ooh, this is an and, a picky one. There has to be intersection here. So I'll get a common denominator. Looks like it's 4, so I'm going to times by 2, times by 2, times by 4, times by 4. So that would be, ignore our denominators. Negative 8x plus 6 is greater than 1. Okay, so we're going to subtract 6. So we have negative 8x is greater than negative 5. Looking here to make sure everything's looking good here. Yes, all good. Divide by negative 8. Well, we have divided by a negative. X value is less than 5/8. Now this will really help us to put into context what we're looking at if we actually rewrite these as decimals, I think. So x value is greater than or equal to negative 1.5. Now it has to be and at the same time, 5 divided by 8 is about 0.6-ish, 625. So x value is less than 0.6. So this one, if you'll notice, goes from, goes that way. So it starts at negative 1.5 to infinity. And notice this one goes this way. So this one starts at negative infinity up to 0.6. Now it's the overlap. So think about it, the lowest value on the left here, look, they're pointing in opposite directions, so they do have overlap. So what's the furthest left we can go? Negative 1.5. What's the highest up we can go? 0.6. So parenthesis bracket, because that's the overlapping values. So that would be your final answer. And then you could even go back to get it more correct. To get it fully correct, I'd want to go back to my fractions. So instead it was negative 3/2 up to 5/8. And then that one had a parenthesis and a bracket. So the set for x such that, remember, put your x in the middle, negative 3/2 here, 5/8 up here, And then remember, it needs to stay munching on the correct thing. Munching on 5/8, munching on x. All right, and then we could draw in our number line. Pretty straightforward. Okay, hopefully this video was helpful on the review. Come with that studied and ready to go. Way to go, everybody. Good luck. Good luck on your first exam.